My name is Kiran, and I'm doing this 15-minute presentation for the course Big Data Analytics. The final project that I've chosen for this course is fingerprint classification using convolutional neural networks. Um, so fingerprints are one of the most extensively used biomarkers for user identification and authentication. And since more and more activities are being done online, it's very useful to have a very reliable and universal biomarker to identify users. And fingerprints have emerged as a very common choice since they have the important properties of being unique, and every person has one, which makes it universal, and also they are invariant over time. In order to have a good fingerprint identification, one of the requirements is that we need to be able to search through massive databases in short time intervals and identify an user fingerprint. In order to develop algorithms which are able to do fingerprint identification in a fast and meaningful way, typically all fingerprints are classified into discrete classes, and then we can use any supervised learning technique to identify a particular input fingerprint to a particular class and then search only in that particular class instead of searching across the entire database. Historically, fingerprints have been classified into various categories based on systems like Rorschach, Henry, and Vucetich systems. Henry system is the most frequently used fingerprint classification system. According to this classification system, all fingerprints can be classified into 5 categories, which are the right loop, the left loop, the arch, the tinted arch, and the word. Here we can see the images for the different categories. This is the right loop, this is the arch, and the second one is the right loop. Figure number 3 is the word, and figure 4 is the tinted arch. Typically, when we try to solve a supervised learning problem, one of the first difficulties that we come across is that we need to develop a system so that we can extract and select features for the given problem. And this can be quite complicated, and it depends on and typically this is done by using people who have subject expertise. But recently, a new class of techniques has come about where we don't need to select the features or extract the features in a manual way. These class of techniques are called as deep learning techniques, and these kind of techniques are able to automatically generate and extract the relevant features for a given problem by using the training data. And such deep learning techniques are based on neural networks. In the general structure of a neural network is shown in the schematic here. It consists of an input layer, an output layer, and it has a set of hidden layers. The nodes in the hidden layers are called as neurons, and typically the neurons in each hidden layer is connected to all the previous layer neurons. And the other property that they have is that they are not connected to any other neuron in the same layer. So by stacking such hidden layers, we are able to solve very complex machine learning problems. For this particular project, the specific kind of deep learning technique that we use is called as a convolutional neural network. The convolutional neural network, or CNN, has the same structure as any other deep learning neural network. The specific characteristic or architecture that is involved in a CNN are that it has 4 layers. Typically, there are 4 layers. The first layer is called as the convolution layer. This convolutional layer is based on performing the mathematical operation of convolution. At a high level, it can be considered as doing a filtering operation. So a filter is applied to local regions of the input image to generate various outputs. And at a higher layer, the effect of doing this kind of filtering is to uh, extract features in the image, like either detecting edges or maybe detecting the orientation of the image or the color. The second type of layer is called as the nonlinear or ReLU. ReLU is short for rectified linear input, linear unit. So this basically converts any given signal into a positive signal including zero. So it basically does a thresholding operation. The third kind of layer is called as a pooling layer. The pooling layer essentially performs a downsampling operation. The effect of this pooling layer is to reduce the computation space for the CNN by choosing only the relevant layers and hence preventing overfitting. The fourth kind of layer is called as a fully connected layer, and as the name implies, the fully connected layer is connected to all the neurons in the previous layer, and it computes a class score for all the input classes that are relevant for that particular classifier. The mathematical operations involved in a CNN are shown in this particular image schematic here. So the input is first processed by the convolution layer, which does some kind of filtering, and then the output of that is passed on to a nonlinear or a ReLU layer. Finally, the next step is to do some kind of downsampling operation or pooling, and then finally we have the fully connected layer, which can be considered to be the output of the CNN. So for this particular project, in order to implement the CNN, the framework that I have chosen is the TensorFlow framework from Google. It provides APIs in various languages like Python, C++, Java, and Go. For this particular project, I choose to use the Python API, and it also provides a great visualization tool that's called as TensorBoard. In order to do this project, I installed Anaconda first on my Mac computer, and once I had Anaconda installed on my computer, then I installed TensorFlow by using the conda command and activating TensorFlow. The database that we use for this particular project is the NIST Fingerprint database. The NIST Fingerprint database consists of 2008-bit grayscale fingerprint images. Each image is 512 by 512 pixels. And out of the 2000 images, there are 400 images from each class of fingerprints. And also the other thing is the resolution is 19.7 pixels per millimeter for the images. In order to create the CNN, the first process involved is to process the input, process all the fingerprint images and the labels so that they can be fed into the CNN that is developed in TensorFlow. And in order to do that, I use some snippet of code that is available from the TensorFlow website. And once this images and labels are pre-processed, the next step is to pass it through the CNN that is developed in TensorFlow. The CNN that we developed, the CNN program that we developed is based on homework 11, where we developed a CNN to classify handwritten digits for the MNIST database. So we use that program as the base for this particular project. So once we have the pre-processed images and labels, and then the CNN program, we train the CNN program and then finally test it by running on some test data. Uh, I was not really able to fully get this uh, program to work because I ran into multiple errors in the TensorFlow program while pre-processing the data and then passing it through CNN. Um, so I don't really have numerical results that I can show for this particular project. Um, so due to the deadline that we have, um, I'm, I'm giving the presentation at the point where I am at this particular deadline uh, time. Uh, so in conclusion, this project gave a good understanding of the complexities involved in solving a real world problem using CNN and TensorFlow. Um, the only thing that I can recommend is that probably more time needs to be provided for the project, especially if people are just working by themselves. In my case, it was just a one-person team. Initially, I was paired with another person, but that particular person dropped out for logistic reasons. So it, I, I really did not have the full, I did not have adequate time to fully complete the project and generate some results. So I would like to conclude my presentation with that. Thank you.